Hello there students! Even some of my craziest videos have reasons to exist, so that's why I'm making a series where I go behind the shenanigans on some of my more... Yep, looks fine. Unhinged content. Today, we're starting off strong and looking at one of my most popular videos. Yes, today's video is on the art of replacing all Team Fortress 2 sounds. As absurd as it may sound, there is quite an interesting concept behind that video. Today, we're looking at Soundscripts and regular expression. Soundscripts are used in Source Engine games as a means of playing sounds. Almost all of the sounds you hear in Team Fortress 2 use Soundscripts, instead of playing the sounds themselves from their files. Soundscripts have support for certain parameters, which make them somewhat versatile instead of simply playing them directly from the sound itself. First, you have volume and pitch. Volume is set from 0 to 100%, while pitch can be set from anywhere between 0% to 255%. Both can be randomised to play within a certain range as well. Randomising things such as volume and pitch are actually used in a lot of sounds when it comes to the game development to prevent certain noises from becoming stale. That's why the footsteps that you heard in that video were pitched. It's because the sound script itself uses random pitches. There's also the channel. In this context, audio channels are typically interpreted by the game's code, and the game plays them, sometimes doing something special depending on what the channel is. For example, if the voice channel is used, and if there is a different sound on the voice channel originating from that player, the old sound will stop, and the new sound will begin.
Bob Medics, a bloodist medic! Yes! Oh!
If a voice clip is changed from the voice channel to a regular channel, that clip will play on top of other voice clips. This is actually why Man vs Machine ready up clips stop your character's current sound and change your phonemes, despite your player not actually saying it.
Ready! Kiss me!
When a person readies up, even if it isn't you, it is played on your model. The ready up clips use the voice channel and only play on the client. Meanwhile, voice clips like the Charge and Targe's Scream are actually not on the voice channel. They in fact occupy the static channel. So if you were to charge using the Charge and Targe, it would actually not play over any existing voice clips. However, this can also be fixed by just moving it to the voice track. And while we're at it, let's just give the sound phonemes so it actually looks like the demo man is saying it. See? All better. Back to the sound scripts. Going on to the other parameters, we also have the sound level. The sound level controls the attenuation. Attenuation means how something can travel before it fades away completely. In our case, a sound. A high attenuation means that the sound fades away faster with distance, while a low attenuation means that the sound fades away slower. Simply put, the sound level affects how the sound is affected with distance. Finally, the wave, which contains a location of the sound file to be played. However, some scripts will use random wave, or R&D wave, which decides the sound from a random selection. Once again, randomization works here since it helps the sound feel less stale. Moving on from Soundscript parameters, if you watch the original video, you'll notice that at one point after I join a community server, a lot of what should be screaming is replaced with the actual sounds themselves. That's because when using Soundscripts, the server takes priority when processing them, not the client. However, there are multiple exceptions. All of these exceptions are Soundscript entries that are played directly from the animation file, instead of some kind of sound cue by the game itself, such as firing a rocket. Now that we've got that out of the way, it's time for regular expression. Regular expression is a system used for matching strings through patterns. Just so you know, string is a term for any piece of text, a series of characters so to speak. When you use something to search, say your browser's find function, you're just searching for a regular text. But when you use regular expression, you can find all kinds of patterns in text, not just limited to simple phrases, but it comes at a price. Regular expression is very powerful, but requires a lot of learning to master, and it could probably be considered a coding language within itself. Even the most simple of regular expression patterns are complex. My video used regular expression to easily replace every single wave entry. This is the regular expression used. It just looks like something I typed by smashing on my keyboard, but trust me. Let's have a look through it. The first symbol what is that even called? Anyway, the first symbol indicates the start of the line. This means the search will start from the very beginning of the line itself. The dot symbol means that any character can be matched, be it a space, letter, number, anything. But what if we had more than one space or no spaces at all? If we had more than one space, the next part, wave, wouldn't be found. While if we had no space at all, the dot character would be the quotation mark in wave, and we wouldn't be able to find what we want that way. That's where the asterisk comes in. The asterisk sorts out both of these problems by allowing any number of characters to be accepted, even if there are none. So from that point on, it keeps going. But if it can't find wave on that line, that means it doesn't match. But if wave is found, it matches everything after that point, leading to the $sign, which means the end of the line. A simpler way to do it would have been this, which just starts the match at wave. But this isn't something that I considered at the time. I used Notepad++'s find and replace tool to go through every line that contained this, and set it to replace the entry with my own. That's the general gist of how I made that video. Regular expression is very complicated, but it can be a powerful tool for strings and parsing string files. Using that, I was able to replace all of the sounds with whatever I wanted, or in this case, that. Goodbye for now, and class dismissed. Okay. Before we stop this video, this isn't scripted or anything. I do feel the need to answer one more question. Like, I've literally just finished making this video. I've just finished going through all the editing. I've just selected all the songs, and I do want to answer one more thing about what goes on behind the scenes. A lot of people have asked me why. Well, there's a very good reason for that. You see, the reason why I did this was because I